Good morning, folks. This is the second lecture of week 8, and what I would like to do today is discuss two joints. One of them is a gearing mechanism, so we'll be using a gear joint and a rack joint. And then, as a second problem, I'll be doing a screw joint. Okay, so for the case of the gear joint, this is the icon, rack joint is right here. And the problem that we're going to be doing is a geared mechanism like so, and dimensions are given here, and you can put some physics into the problem by specifying, for example, the angular velocity of the pinion if you want, and then that will give you, it'll result in a motion of the rack, and the rack will have a linear velocity that if you want you can actually recover. Now, just to point out that it is possible to do many of these problems instead of using gear joint, using a roll curve joint. For example, you notice that this circle rolls on that line, or the pinion circle rolls on the circle associated with the bigger gear. But and there's no issue with that as long as you do it correctly. If the problem is given, unless you're specifically to use gear or rack joint, you can use roll curve joint if you want. And the second problem that we're going to do is the C-clamp mechanism, where we'll be using screw joint. All right? Good luck. What to do is to save this thing, file, save management, save as, and I'm going to create a folder called July. Okay, that is July 6th. July 6th, new. Okay. And first thing I'm going to do is that base where the gears are going to get mounted on. So insert a new part right here. Insert a new part in there, and I'm going to call this thing the base or the wall if you want. I'll call it base, and base. Okay, let's make it. So on a convenient plane, on that vertical plane, I will sketch a rectangle. Something like that. Let me give these dimensions. So this is 6 inches. 6. This one is 4.5. 4.5. Okay. And then I'm going to make a little circle here. Now the radius of that circle, diameter of that circle is 0.5. That's the shaft of that gear. So radius 0.25. Okay, and it's mounted like this. So the distance from there to there is 1. And the distance from here to here is 2. Okay, and then the big gear is going to be mounted into a second hole here. The diameter of it is the same as the other guy. The radius of it is 0.25. And the distance from that point to this point is, I believe, 2. Okay. Right. So what we have here is basically this configuration over there. So exit, and then we're going to pad it. I'll make that thing 0.25. Yeah. You go all the way to the top, and I'm going to make the two gears by actually drawing something and then shafting it. It is possible to draw a pad and another pad on that, or a multi-pad, but I'll do it differently, okay? So insert a new part, say no, small gear first, right-click properties, small gear, and right here, small gear. Now let's make it. So for example, on this plane, I will sketch something that looks like this. I'll fix it in a minute. Okay, so the diameter of that small gear is 1, which means the radius is 0.5. So if I dimension this, that's going to be 0.5. That's going to be the radius, of course. Okay, oops. And then this guy is the shaft of that gear. So by the way, while we're at it, so let me also make this thing 0.5. 0.5. Okay, and this dimension is the radius of that shaft, which is 0.25. 0.25. And why don't I make this height all together? Why don't I make this thing maybe 2 to see how it looks like? Yeah, that's pretty good. Exit. And then shaft it about that line. And this is going to be my small gear or the pinion. So we're going to go all the way to the top, insert a new part in there, say no, that's going to be the big gear. You come down here, big gear. Let's make it. Double click on this. And let's see now, once again on that plane, I will sketch something that looks like that, except that the diameter of it is bigger. Diameter of that top piece there is 3. Okay, so let's draw it for now like so. Oops. Close that. Incidentally, you know what? I'm not going to close it. I just want to show you that you can also use the axis, because when you do the axis, automatically if it shafts it about that, you don't have to close it. It takes this thing and shafted about that. I could have drawn a line and shafted about that line, but on purpose I did something new. Okay, so let's go ahead and do these things. This one is 0.5. That thing is 1.5. And this, the distance from here to there is the same as this distance, which I believe is, looks like 2. I'm not sure. Let me measure. What is it between this and that? 2. Yeah, that's good. All right, good. So if we, oh yeah, this thing is gotta be 0.25. All right, exit. Automatically, it's going to get revolved. Oops. Oh, shaft. Yeah, there. Because I had an axis there, I did not have to actually select the axis of revolution. That's fine. So we go all the way to the top. You have almost everything here. The only thing that we have to do is to insert the rack. insert the new part. No. And we're going to call this thing the rack. Rack and rack. Let's go make it. All it is a box. So on this, for example, vertical plane, I will sketch a rectangle, something like that, something like this. And this height is 1. Exit and pad it by 0.5. Okay, all the pieces that we want are made. So let's go all the way to the top level. Click on the floppy so that it saves everything in case things go crazy. All right, let's anchor the base. Okay, let me mount these two. So coincidence between this axis and that axis, and coincidence between this plane and I want to select the bottom of this, but I can't see it. Let me show you a trick. If you put the cursor there and use the arrows on your keyboard, the 4 arrows, up, down, left, right, it actually walks you through anything that you can see. Now notice that that's what I want. If it's too much of a hassle, rotate it and select it. Okay, if update, let me see. If you update it, it should jump back to that thing right there, except that the direction is not right. So just go ahead and that constraint, the last one, flip the arrows. Either you put the cursor there, flip it, or you go to more and say instead of the same, you say opposite. It doesn't matter. There. Okay, good. Now let's mount the other guy. So coincidence between this axis and that axis, and coincidence between that plane. And once again, let me show you that trick. You put the cursor here, you use the upward arrow, you just march through anything that you cannot see, which obviously is this. And I may have to flip the arrows, I don't know, we'll find out. And I do. Flip it. And up. Good. So the situation that we have is right now something like that. Very good. And now let's go and do the coincidence between, how about doing, for example, that's entirely up to you which faces you want to take, but I'll select this and that. Okay. And then coincidence between this line and that'll be, I guess, that line. Okay, let's see if it works. Ooh, something didn't like. So let's check it out. What is it that we did? Oh yeah, okay. You can see what happened. Undo. Let me undo this. Undo. Okay. So as far as the faces go, this is okay. Yep. Let me move these things closer to each other. Okay. So as far as faces go, is that bottom face and that face. Okay. So that's fine. And as far as the edge goes, let me update this first. Okay, good. And as far as the edges go, so edge between this edge and we hide that edge. That should work. Where is it? Oh, did I hide this? Oh yeah, right there. I'm sure that's okay. It's okay, except that this height, this height should have been 1. I made this thing, that height should have been 1. Okay, so let's go back there to that rack that we drew, that sketch. This height, I forgot to make it 1. What did I make it? Maybe that should have been 0.5. I don't know. 0.5? Let's find out. 0.5. Is that better? It looks like okay. Yeah, okay, that's good. That's good. Now, let's go all the way to the top and save this. Good. And actually, let me move this guy a little bit to the right. Good. Now, first of all, these planes, I don't want to see them. Okay, so how can I hide them? You can do right click. What? Let's see, view. I guess toolbar. No, let's do it like this. So you go to edit, search. In here, type planes, plane. And this is search and select. See that? Search and select. See this binocular and a pointer? Search and select. And once they pop up, just say hide them. And you know how to hide it, right there. Or right click hide, either one. It's just that. And the constraints, I don't want to see it either. So I'm just going to do it like that. Hide it. Good. So what we have is, when we go to the digital markup and use the magic wand, there's going to be a revolute here, and a prismatic there. Okay? Now, let's go there. So digital markup, DMU kinematics. Get the magic wand out. Use the magic wand. New mechanism called mechanism 1, auto create. Now notice that here it says 3 out of 3. Say auto create, they're all resolved. That's good. So there will be 2 revolute and 1 prismatic. Let's check it out. Yeah, 2 revolute and 1 prismatic. Now, the degree of freedom, of course, is 3, because you know that a revolute has 1 degree of freedom. There's 2 of them, that makes it 2. And the prismatic is also 1 degree of freedom. So altogether, there's 3. Now, what we want to do is, there are different ways of doing gear train, but I'm going to use specifically that icon. See, first of all, in the DMU kinematic, click on this downward black arrow. It shows you all the joints. And if you go to the right, you see here it says gear joint. See that? Gear joint. You click on it, it says, okay, I'm going to create a gear joints for you, but I'm hungry for 2 revolute joints. Since I already have them, I can create them. If I don't have them, you can go and create it. So let's do that. We already have one here. So revolute joint 1, this is the small gear, and this is the big gear, okay? And they go in the opposite direction because these are external gears. You click on the opposite here, and the ratio, this right now, the ratio is -1. So what I want to do, so the ratio, I define the ratio between these 2 circles, because you know the gear ratio is the ratio of number of teeth, or which is proportional to the number of the radii. Okay, so this will be this and that, and that's a gear ratio of 0.33. So for every revolution of this goes by 0.33. Okay? Say okay? Good. And the angle driven for revolute 1. So remember I selected this to be revolute, this guy to be my first revolute. So I'm going to say this is going to be angle driven. Okay? You see that? When I was selecting, I selected that guy first. That's the driver. Okay? this guy is the driver. So that's why I said angle driven for Revolut 1, not this other guy, which would have been Revolut 2. And these should have been opposite, by the way. Yeah, opposite. Okay, good. So now what happened is the gear joint has been created, but it gobbled up my Revolut joints. Now we're going to go and do rack joint. There is a rack joint. See that? Rack joint? You click on it. It says, okay, you need a prismatic one. No problem, I've got it. But I also need a Revolut one, but I got gobbled up by gear joint, so I have to go and create it again. So you click on the create right there. See that? Create. And it says line and line. You know how to do Revoluts. You go there. You select this line, hide that, and you select this line. Zoom in if you have a hard time. And the plane, it has to be same order. So this plane and this plane. And if there's a mistake, of course, you're going to make it. And hang in there. I think this plane, let me cancel this. Try it again. Create this line and that line. And for planes, this plane and that plane. Otherwise, I need to define offset and things like that. So that's okay. And this is length driven, right? Now, as far as the ratio is concerned, this is already calculated correctly, okay? Let's check it out. You define, you select that radius, and it's going to give you that ratio. What that means is that it advances that many millimeters for every turn of this big one. And it is length driven, right? Length driven. I guess this last one, let me see for a second. Let's check it out. The degree of freedom came out to be 0, which is a good sign. So let's go ahead and see whether it's working. Now I got a warning or error message that I didn't like, but anyway, degree of freedom is 0. So let's check out, see whether it works or not. So here is the simulation with command. And if you want to simulate it, change some commands. There are too many commands. Okay, no problem. That's fine. Let's go to that rack joint. I make that thing length driven. Let me take that off. I say okay. Okay, now mechanism. That second one I did not have to do. Remember, I made this thing angle driven. I also made this thing length driven. Obviously, that is cannot be done because once this is angle driven, when this big gear moves, because it's a rack gear, it moves that rack with it. Okay, no problem. Let's try it. There we are. Now, you might say, wait a minute, how do I know if these are rotating? Let me show you something here. If, for example, I go, let me do this. If I go to base, if I go to the, not the base, a small gear, and on this, I make a little indentation. So select a little circle, because I want to see whether this is actually rotating or not. There we are. And exit. You see there's a circle there. Now let me go to this guy. On that face, draw also a little circle. Exit. Okay, good. So the two circles you can see here. You go all the way to the mechanism. Okay. And now you simulation with command. Just watch it. They are moving. You see that? You see? Good. Now reset. What I'm going to do is I'm going to change the range of motion from 0 to 360. Okay, now you can see that when I turn it, It does what it's supposed to. Okay, reset it. Good. Can I make a simulation? Yes, I can make a simulation. So where is that thing? I don't need this anymore. I'm going to close it. So this is going to be simulation. Drag this thing all the way to the end. Insert. And change this thing to anything on one and make it go back and forth. How about that? So it goes forward, and it goes backwards, and it goes forward, and it goes backwards because I made it look like that. Right here, I use this loop change mode. Okay, now stop it, rewind. Okay, no physics. So let's put some physics into it. You click on the f of x, click on mechanism. This is the angle driven. This is the pinion. Remember, I said add a formula equal to 360 degrees. Oh, actually 120 RPM, right? So that's 720 degrees. 720 degrees per second times time, variable time, which is right here. Double click on it. That's the physics. And let me see now. If I want to check the correctness of this, what I can do is that I can plot the velocity of this point on the rack, which is going to be big R times omega. Omega is 4 pi, right? 120 RPM is 4 pi per second. Multiplied by that radius, it shows 1.5. You better give me the velocity of this. So let's go ahead and do this. So ball rolling down a ramp. This is the point. The reference product is the base. The point is here. Say OK. And then I'm going to say simulation with laws. Where is that? Right here. Right there. Simulation with laws. Over a 2-second period. Now 2 seconds, this is going to turn four times. So make it 1 second, okay? 1 second is going to turn, this is going to turn two. Actually, you know what? Let's make it 4 seconds. 2 seconds, okay, no problem. Okay, good. Activate sensor. If I say, give me the speed, linear speed, obviously it's going to be at that point. The answer is going to be R omega, right? R omega, R is 1.5. The radius of that big gear was 1.5 inches. R omega was 4 pi. Right, omega was 4 pi. So times 1 is going to be 1.5 times 4 is going to be 6. 6 times 3-ish is going to be about 18, 19. Okay, so good. So better get 19 inches per second. So play it. No problem. Graph, we better get 19 inches per second. Oh, wait a minute. Let's check again. What was the speed? 720 degrees per second. That is 2 pi, right? 700 degrees per second is in 120 RPM. There were 2 rounds per second, and each round is 2 pi. So that's going to be 4 pi times the radius, and the radius of that thing was 1.5, right? So 4 times 1.5 is 6, times pi is 6 times 3 is 18. So why am I not getting correct value here? So something is definitely not right. Let's check something. Let's check. Say OK. Close that. Rewind it. No problem. I want to measure that radius. I want to measure this radius. 1.5 inch R, yeah, this is R, times omega. Omega was, let's check it out, 720 degrees per second. So that is 2 rounds per second times 60 seconds. It's 120 rounds per minute. That's okay. So why am I not getting your R omega? So omega 100 omega is 4 pi times the radius. Yeah, I'm not getting what I expect. Let's check this. Simulation with laws. Activate sensor. Speed. Okay. Inch per second. That's correct. Oh, I'm sorry. I'm sorry. That 120, 120 RPM was for the pinion. Okay, remember the speed of that big gear is actually the 120 times the gear ratio, which was roughly 0.3. Roughly 0.3. So this number that I said, this calculation that I did, you have to multiply it by 0.3 to get the speed of the rack. That 120 RPM was the speed of the pinion. The speed of the big gear is that 120 in RPM times the gear ratio, which was, I believe it was 0.3. So the angular speed of that big gear is actually, this omega is less than whatever the pinion has. And when you work it out, you get that same number that I had. Please go ahead and work it out. That's good. So remember that when you generate these speeds, these figures, you have to save that as a PDF file or as a Word document because there is no record that you have done it. Okay. What do I mean by that? Go there, activate sensor, play it, graph it. There we are. This one you have to zoom out, print screen, open a Word document, paste it. And if this is the graph that I asked you to generate, save it, save as, browse. It was July 7th, I believe, July 7 new or something like that. July 6 new, sorry. My plot to be marked. And this is going to be in that folder. Although there's no record that you have done it in the CATIA, but if you go to July 6 new, there it is. I can open this up and find out what you have done. You have to zoom out, make sure I can see all the numbers and all the units. Okay, so let's go ahead and do this other problem. I'm done here, so let me get rid of all of this. The second problem that I want to do for you is something like that. This is, I call it C-clamp, but you know, this is what you do to secure a piece of wood if you want to paint it or you want to saw it, etc. And this is where you're going to have a screw joint. Okay, so as you turn this thing, this guy advances. This bottom part advances by a certain amount. That's what a screw joint is. For every turn, you have a pitch, which is the amount by which it advances. I'm not going to worry about dimensions here. So let me go ahead and just make this thing based on the dimensions that are above. So I'm not going to put any physics into it either. So product. Okay. So insert a new part in there. I'm going to call this thing the clamp. Clamp. And clamp. Let's make it on that vertical plane. I'll use sketch. Yeah, something like this. Okay, exit. Pad it. Okay, good. On that plane, I will sketch. I want to make a hole there. Yeah. Like so. Exit. Make a pocket in both directions, all the way to the top. Okay, good. Oh, actually, not on the top. On the top, I want a gadget like this. Okay, so no problem. So actually, don't go all the way to the top. Okay, that's good. Okay. On that bottom face, on that face, I will sketch. Why don't I project that circle? I'm trying to minimize my work. So right there, you can see that. Exit, exit. Right there. Make a pad. Okay, that's too much. Maybe 0.3, 0.4. See how it looks like. Yeah, okay, that's fine. And on that face, I will sketch. Let me change the rendering here so that I can see what's going on. It's that circle, right? I can see now. Let's see, what is it? Oh, yeah, on that. Okay, good. I'll draw a circle here. Okay, let's make these things concentric. That guy control this fellow. Okay, and then exit, pad it a little bit. Yeah, 0.2, that's fine. Okay, so what you see here is what you see there. Okay, now the handle. Now this thing and the handle. So let me go ahead and do this. So we go all the way to the top, insert, new part, say no, and I'm going to call the handle, properties, handle. This is the instance name, handle. This is the part name, make it. And so just to make what's going on that plane, I will sketch just so that I can see what's going on here. The different ways of doing this thing, for example, I can do it like that. Let me draw an axis here first. Please remember, there are many ways of doing these things. Okay, and then I draw my sketch, something like that. Okay, and let me finish this thing, wrap this up. I have to come back and fix this thing. So exit, when you exit, and then you shaft it, it will create that thing for you. The only thing is that I don't know, these dimensions may not be exactly the same. That's okay. We don't care. The only thing is that I need a handle down here too. So let me go back to that sketch. Oh, not there, not that sketch. So what I can do is different ways of doing it. For example, on that plane, I can sketch. Why don't I draw a little circle like this? Exit. I don't care where it is, it doesn't matter. And then pad it. So this is going to be playing the role of my handle that I can turn. Okay, that's good. So now we're going to go all the way to the top, save everything. I'll take my chances. I'm not going to save it. Let me go to assembly design first of all, assembly design, and make sure that this is centered about that hole. So let's actually fix that base, okay, or clamp. Coincidence between this line, and let me hide that, and this line. I just want to make sure that these are coincident. Update. Okay, good. Now I'll bring it down. There we are. Okay. So that's pretty much it. So let's go ahead and as a matter of fact, you can see that I can even delete this. I don't need this, okay? So we're going to go to digital markup, DMU kinematics, get the magic wand out. It tells you that there are no constraints, so this is fine. I understand that. So what we have to do is notice there are no constraints. If I had not deleted that guy, that axis to axis, it would have created the cylindrical joint for me. But I want to show you something here. So you go to this list of all the icons that you've got, and you will find something called screw joint. It's right here, cylindrical, screw joint right there. You click on it, it says, hey, all you need is 2 lines. So I want this line. First of all, new mechanism. Yes, I want to create a new mechanism. Good. First line is this line, and I'm going to hide that. For the second line is this line. And remember, these screw joints are either length driven or angle driven. Let's make it angle driven. So for example, and the pitch, this is in millimeters. So for every turn of this, how many millimeter it advances? Now, let's make it 10 millimeter. I don't know how to change this thing to inches. I'm sure there is a way to do it, but let me leave it like that. Let me put 20, maybe 10 millimeters. Okay, 10. Okay, that's going to be millimeter. Because if I try to make inches here, type inches, it won't take it. So there must be, this unit is millimeter, I'm sure. So we say, okay. Notice that a joint has been created right there. Screw joint. Where is the handle? Okay, let's go here. So let's try it. Simulation with command. Oh, fixed part. Okay, that's fine. So although this is fixed here, but this fixity happened because I didn't assembly design. And remember, it says that you have to add a joint here. Look, right there. See that? Right there. There is no fixed part here. You can see that. You click on this. You click on that. See that? You click on this. And new mechanism. Okay, I don't like this. You know what? Why don't I delete this? I deleted that. Let's try. Okay. First of all, let me fix something. Okay. I'm going to fix this guy. New mechanism. Yes. Fix something. That is fixed. Okay. Now we're going to do that screw joint. Screw joint. This one. 2 lines. Okay. This line. And I'm going to hide that. This line. Pitch. You said 10 millimeters, right? Every and we're going to make this thing angle driven 10 millimeter. Okay. Every turn of that handle advances this thing by 10 millimeters. And we say, okay, mechanism can be simulated. All right, where's that guy? Let's bring it in the show mode. There we are. Let's try it. There is your simulation with command. Let's go 0 and 360. Okay, so if I turn this thing, this should turn and it should advance. The amount of advancing is that pitch, which is 10 millimeter. So you see that? And if you don't believe it, we can always measure it. For example, let's start down here. We measure between this point or this surface and that surface. It says it's 0.92 inches, right? 0.92 inches. Okay, let's move it up. And now measure it. It's more than 0.92 inches, and that difference is the 10 millimeters. Okay? So that shows you how to use this screw joint. All right, folks?